All right, good morning. Well, it's probably evening for you, but it's morning for me. Today we got 6-5 notes, and we're going to take it back old school. Now, remember back in the day when you had a problem like this. We have 7,443 all divided by 3. So that's right, we're going long division. So we would take 3. How many times does it go into 7? It'd be 2. 2 times 3 gives me 6. And then we subtract that number. 7 minus 6 is 1. And then we'd bring down the next digit, which is 4. Then we divide and do that process all over again. So 3 goes into 14 4 times. 4 times 3 gives me 12. Subtract. 14 minus 12 is 2. Bring down your next digit. 3 goes into 24 8 times. 8 times 3 is 24. Subtract, you're left with 0. Bring down the next digit, which is 3. 3 divided by 3 is 1. Multiply, and bam, you're left with the remainder of 0. It worked out perfect. So 7,443 divided by 3 is 2,481. I hope we remember that process. Let's look at another one. We'll still keep it back. 9. And we're going to take 5,744 divided by 9. Alright, so 9 goes into 5. Well, 9 can't go into 5. So if it doesn't go into the ones digit, we jump to the 10 digit. So you jump in a sense where you can get in. Alright, so 9, that's an important fact to remember when we take it a step further in a minute here. 9 goes into 57 6 times. 6 and 9 give me 54. When you subtract, you get 3. Bring down your 4. 9 goes into 34 3 times. 3 and 9 give me 27. Subtract 7. Bring down your 4. 9 goes into 74 8 times. 8 and 9 give me 72. I'm left with 2. Alright, with no more digits left to bring down. So we have a remainder of 2. So remember, 5,744 divided by 9 equals 638, and then your remainder over what you divided by. So it's really like 638 and 2 9s, so plus 2 9s. Alright, so that's just a refresher of how we do long division. Now, why did I do that? Well, what we're going to talk about today is dividing polynomials. So the first example is going to be like this. Now this is very important, so take detailed notes. We'll get into it more in class tomorrow. And the problem is going to look like this. X to the third minus 4x squared minus 19x minus 14 divided by x minus 7. Say, what? Alright, so now we're going to use that same process of long division to divide these two polynomials. So leave a little space here because we're going to do some work up here. So I'm going to start right here. And inside I have x to the third minus 4x squared minus 19x minus 14. And that's all being divided by x minus 7. Now, where we're going to start is, when you do this, you start with dividing by that. Now, up here, we decided 9 can't go into 5, so we jump to the 10th spot, which is 7. Now, this is the same idea here. Okay, if you take x to the third and divide it by x, so if you take x to the third and divide it by x, you're going to get x squared. Let me do that in a different color so it sticks out. Actually, so that's how you decide. You take the highest degree and you divide it by this first term here. All right, and that's going to kind of tell you where you start, where you can get into the problem. All right, now, then it's just like up above. We take this and we multiply it by x minus 7. And that's what we're going to subtract. So we're going to subtract, and I like to do the work off to the side so you can see it, x squared times x minus 7. All right, and watch what happens when you multiply that out. You get x to the third minus 7x squared. Then we subtract those two. So now by doing this, what it always allows this front term to cancel. All right, and then we have negative 4x squared minus 7x, negative 7x squared. So minus and negative is the same as plus. So I got 3x squared. All right, bring down your next term, just like we did above. So it's the same process. We're just dealing with variables, so it's a little more difficult. So now we take our first term, which in this case is 3x squared, and we're going to divide it by the first term here, which in this case is x. So 3x squared divided by x gives me plus 3x. Now 3x times x minus 7, and that's what we're going to subtract. 3x times x minus 7. So I get 3x squared minus 21x. We're going to subtract those two. So 3x squared minus 3x squared, that term's gone. Negative 19x minus negative 21x, again minus that negative, gives me positive 2x. Bring down your 14. So take your first term, which in this case is 2x, and divide it by the first term here, which is x. So that gives me plus 2. Then I'm going to take 2 times x minus 7, and that's what I subtract. And I get 2x minus 14, subtract. The 2x's are gone. Negative 14 minus negative 14 is just like adding, so I get a remainder of 0. Alright, so my solution, basically what I did was I took x to the third minus 4x squared minus 19x minus 14, all divided by x minus 7, and it gave me the solution of x squared plus 3x plus 2. Alright, let's try another one. And then we're done. One more. Alright, we're going to go 2x to the fourth. So we have 2x to the fourth plus 3x to the third plus 5x minus 1, all divided by x squared minus 2x plus 2. Now, when we set this up, you have to be very careful because something occurs here. I notice we have 2x to the fourth plus 3x to the third, but however we're missing our x squared term. Now it's very, very important that we put a placeholder there, because otherwise it messes up our whole process. So whenever you're missing something in standard form, it has to go in descending order. So in the event there's not a term there, whether in either piece, all right, we like to put that placeholder to remind us of the process that needs to be done. All right, so here we're going to take 2x to the fourth divided by x squared. So think about it. Where is that going to put me in? 4x squared divided is going to give me x squared. So we're going to come in right here. Now that's where you got to decide. That's a decision you have to make to decide where to start. So when I divide that, I get 2x squared. Now begin your process. 2x squared times this piece is what you're going to subtract. So 2x squared times x squared minus 2x plus 2. So 2x squared times x squared gives me 2x to the fourth minus 4x to the third plus 4x squared. So we have to have that placeholder so that we can complete that arithmetic. So here I'm left with my first term's gone. 3x to the third minus negative 4x to the third gives me positive 7x to the third. 0x squared minus 4x squared is negative 4x squared. Now bring your next term down. Alright, then we take 7x to the third is my lead now. 7x to the third over x squared. So that gives me plus 7x. Multiply it out. 7x times x squared minus 2x plus 2. So that gives me 7x to the third minus 14x squared plus 14x. I subtract. First terms are gone. Negative 4x squared minus negative 14 is the same as plus. So that gives me 10x squared minus 9x. Bring down your next term. So I have 10x squared divided by x squared gives me plus 10. Multiply it out. So you have 10 times x squared minus 2x plus 2 gives me 10x squared minus 20x plus 20. Subtract them. First term's gone. Negative 9x minus negative 20x gives me positive 11x. Negative 1 minus 20 is negative 21. Now there's no terms left to bring by, so this is your remainder. Now remember what we did with the remainder in the first one. All right, in the old school examples. Okay, so my answer is going to look like this. It's 2x squared plus 7x plus 10 plus your remainder, which is 11x minus 21, all over what you divided by. X squared minus 2x plus 2. All right, just like we did up there with the 2 nines. However, in this case, it's a polynomial division. All right, so that's long division in the whole. Tomorrow when you get to class, you're going to do a warm-up. I'm going to check these notes. We'll have some time to get started on our work. And then we'll learn a new method in tomorrow night's video. All right, see you in the morning.